Austin, so I'm going to go ahead and mark him down really quickly as being done. Okay, David, if you wouldn't mind just texting them and filling them in on kind of what we've been doing. Yeah. You can look at the video, but just be like, hey, if you need anything, Misty just wanted me to check in and make sure that it's something that we can do to support you or help them out. In our motion packet, we do want to go ahead and go through and grade not only, what are you supposed to have attempted for today? Worksheets 1, 2, and 3. Sorry, not 1, 2, and 3. Well, technically, worksheets 1, 2, and 3. Worksheet 1 we did together, right? That was the very first page. And that was the one, are you not going to scroll? Hi. Okay. Worksheet 1 was the one that we filled in together with like time, position, velocity, right, left, negative, all that jazz. And the final total distance traveled we finished yesterday to be 36, right? Worksheet number 2, examples 1, 2, and 3. Hi. That's what you were supposed to have attempted 2 nights ago. And we went over total distance traveled yesterday, which was, for example, 3, number 4, part 4 of example 3. And then, what did we add yesterday?
Number 4 and worksheet 3.
Number 4 from example 3, worksheet 2, and then worksheet 3. Worksheet 3 was super different than worksheet 2, though, right? Mm-hmm. Worksheet 2 was very much like, hey, you're a problem. You're given a table, use it. You're given a graph, use it. You're given a function, use it. Worksheet 3 was like, hey, let's deal with these concepts a little bit. And so we're going to see how well the concepts went. But first of all, color pens, I have the answers up here for each of the worksheets. Let me see if I can make this a little bit bigger. I think there's a full screen option. I just always forget where it is.
Is the spot check on the worksheet? Or what's the spot check?
We technically went over the bookwork yesterday. I probably should have done a spot check then, but we were just trying to get things done. Can I full screen this? I swear I can. Oh, full screen mode. There you go. Okay. Here we go. Example number 1. Okay. Example number 1. At t equals 0, the particle is moving to the left. But you weren't supposed to just write the left. This is worksheet number 1. Sorry, worksheet number 2, example 1, the one with the table. Okay? Number 1, moving to the left, but you were also supposed to justify it. You did not in your color pen write because the velocity at 0 is negative. V of 0 is negative. You could have also written a negative number and been like, hey, it's less than 0. Any questions about number 1, how to answer? Moving left because V of 0 is negative. Number 2, yes, but why? What were they asking? They were asking, must there be a place where V of t is equal to 0? And what were you given in the table? Select values of velocity, right? So then we're looking at actual velocity values. We're thinking about velocity as a function. Is velocity continuous? Yes, all motion is continuous. You can't randomly be going 5 miles per hour and all of a sudden be going 40 and not have gone through all the speeds in between. That makes sense. Velocity is continuous, so therefore by, my hint was IVT. By IVT, since velocity goes or changes from a negative to a positive, and specifically, guys, when does that happen?
Negative 3 to 2 or time.
The values were negative 3 to 2, but the times?
0 to 2.
0 to 2?
0.
So I would actually say, since velocity goes from from negative to positive for t within 0 to 2, even though you are going to be able to say 0 to 12, a better way of putting it is velocity goes from negative to positive for or on the time interval 0 to 2. Then velocity must go through 0 at some point on that interval. We could say at some time on that interval. That might be a little better way of putting it. At some time on that interval or in that interval. Indicating that the particle is at rest. So when I said at rest, you had to think velocity equals 0. Look in your table saying velocity continuous. If it goes from a negative number to a positive number, which it does here to here, yes, velocity must be 0, meaning the particle must be at rest at least at one time because of the intermediate value. Because of the intermediate value. Don't write that whole paragraph, but the idea is velocity is just naturally continuous and differentiable. We can always say that. Same thing with position, same thing with acceleration. So IVT applies. The sign change says yes. Number 3. Yeah.
Does the AP test, like, is IVT,
IVT, they totally know exactly what you're talking about.
Oh.
IVT, NVT, EVT, they should know that one as well. They should know EVT. But I rarely see that one actually required in an FRQ. IVT and NVT are very common. Number 3, they're asking, I believe, check me for an approximate or an estimate of the acceleration at 10. Is that right? Okay. Well, what's the problem? First of all, it's 10 in the table.
Yep.
And now it's in between 0 to 12, but 10 is not actually in the table. So my hint to you the other day was, since you cannot look at what's going on at 10, you can't look at the velocity at 10. And even if you could, we can't take a derivative because we don't have a function, we don't have a graph to look at a slope. We know nothing about what's going on at 10. The best we can do is do an average rate. We can't do the instantaneous rate to find acceleration. Acceleration is naturally the derivative of velocity. If we can't do that, the best we can do is the average rate of velocity, which is f of b minus f of a, but since we're trying to find the rate of velocity, it's v of b minus v of a. Plugging, 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 we get -1/2 meters per minute, or meters per minute squared. These are both okay. This one's probably preferred. But these are both okay. And technically, kiddos, if this was a long answer, I wouldn't even want you to write that. Guess what I would want you to do? Box this. Because what happens if you try to simplify an FRQ and you simplify wrong? You just lost your point. But if you box that, they're like, well, that's a smart kid right there, and I'll give them points. Every teacher who helps grade the APs for calculus comes back telling their students, don't you dare simplify, because I had to mark way too many points off of kids who had the right calculus and did the wrong. Okay. Anyway, coming back. The best approximation that we have technically is -1/2, or plugging into your formula meters per minute squared. Yes, you do need the units. Number 4. Why are they using MVT? Did anybody figure out my hint and why I said MVT? Okay, why MVT, Charlotte?
Because the time between 6 and 12 is the velocities.
The time between 6 and 12. So they gave us the interval 6 and 12. They actually weren't asking for velocity. What were they asking for? Acceleration or v prime. And since we had velocities in the table and they're asking for the derivative, what theorems guarantee derivative values? MVT or Rolle's. Could you have used Rolle's theorem? Yes. But can't you use MVT because he's the big umbrella guy who covers Rolle's? Rolle's is just a specific case. So on the AP, they almost always use MVT. They rarely state Rolle's, but it would have been helpful to think Rolle's because they said, must there be a place where acceleration or v prime is 0? 0, Rolle's, f of a equals f of b. Is there a place where v of a, where the velocity at a equals the velocity at b in the table?
Yes, 5 and 12. Oh, wait, no, 6 and 12.
Yeah, at 6 and at 12. At 6 and at 12. You could have actually shown the MVT formula and plugged in, or you could have said v of 6 equals, what is it, 5?
V of 12.
But does it actually equal 5? You could have stated this instead, since v of a equals v of b, since the value of the velocity at 6 is the same as at 12, and since my velocity is continuous and differentiable, I can say by Rolle's, or you can also say by MVT, because remember, Rolle's is just specific, MVT is general. By MVT, booyah, yeah, there must be a place where the derivative is equal to 0. Remember, if we can show the ifs, we can say the then. And we just have to state the theorem that says it's all.
How can you say that? How do you know that velocity is differentiable? Velocity always is differentiable.
People don't disagree. Motion is always differentiable.
Okay.
So that's something for you guys to stow away. You don't have to prove it. You can just state it because of
This doesn't
just the
make sense.
behavior of of motion and a lack of time travel. I don't know. Anyway. But yeah. From this point forward, you can always just state, or you can always just assume position, velocity, and acceleration are always
But what if you have a
undifferentiable.
sharp point.
Well, sharp points can exist in graphs, but how do sharp points exist in motion? How would a sharp point exist in motion? What would be happening? There is an exception where a sharp point can occur.
Like a sudden movement.
A crash.
Yeah, but that's not. It's still not a sharp point if you were to zoom in enough, because it's not
Because
an instantaneous change. It's just happening over a very short time, isn't it? I mean, even
it
if
depends
it's
on the
gone-
type of crash.
But doesn't it after it crashes, it doesn't move after?
Right, so it's going to level off. Meaning, like if this is my position, we could say position, you're getting farther and farther away from something, going at faster and faster speed. When you crash, your velocity, instead of being like positive because I'm increasing, moving to the right, velocity is going to level out. So here's what we're looking at, is that change. Because when you crash, your position is staying the same, nothing's changing, right? With Tyler, I think what you're thinking of is two objects, an immovable and then a movable.
Well, sure, but even if it's, are you saying like if it's elastic and if it's like a ball bouncing off a wall or something?
Yeah, I was thinking of a fixed object that's not moving, that it's bouncing with.
Because even if that happens, it should be like
the ball
the
doesn't
velocity function. Or
I was thinking position function, velocity being the slope.
Oh well, then.
Because the ball's speed is not affected by the wall, because it's not slowing down. Like if it's a person, they'll slow down if there's a wall coming. But a ball is just going to go, and then suddenly it's going to hit with an impact, hit with the speed, but then it's going to. We'll see a ball. I was thinking a car with a wall, and the wall's not going to move. Not that a wall can't move, because obviously the car can go through, and that would be a different case. But like something that's not going to move, that's not going to. A very strong wall. There you go. Alright, someone who's not paying attention. I don't know, it's a good question. I would think that would be a sharp point, because then it hits with this speed, and yet, then after it's a zero, I don't know how that transition would look.
Because I think the collision would have to happen like an infinitely small time, like a point, because its time is the x-axis. So.
But if the person's not paying attention, there's no slowing down coming into the wall. So the question is what's happening at the impact.
Yeah, like I think it would have to be infinitely short to be able to be represented in a single point, like that change in. Like I would think it would,
That
if you
makes
zoomed
sense.
in enough, it would be a curve.
Yeah.
Whether,
Because the start of the impact, there is going to be,
yeah,
in
there's
physics, is
slowing
going to
down.
be
So it's like the wall
a
is gonna,
progression.
the wall is exerting a force on the ball, and it's gonna be decelerating in the, or it's accelerating in the
And
direction
then, well,
opposite
and the whole
motion.
shape of the ball is, right? Because depending on the type of ball, it's going
It'll
to actually be
compress as
absorbed, and
well.
then it's going to.
Yeah.
With a car, I guess it'd be the same thing. So it's going to look like a sharp point, but even then, it truly won't be.
Yeah.
That makes sense.
Should be.
Trying.
Okay, but what if like you have a waffle, like an Eggo waffle, and like I know it
It's
sounds so stupid, but you trip and you fall, and so like it falls and it hits the floor. Like wouldn't that be like?
The floor exerts a force on the waffle.
If you
It's
do like
like
that,
the waffle just like
It
stops.
doesn't instantaneously stop. It stops enormously fast.
that would be even better though, because then it'd be a gradual. So that wouldn't be even. Sarah wanted to drop it in her mouth. Anyways, let's come on back. Let's get away from the waffles. All right, cool kids. Basically, there's a lot of physics at play. But what Tyler was saying is making sense. I wasn't thinking about the compression of the car and how the wall is going to absorb. Yeah, see, then that's all the physics stuff that I don't usually teach. And so in my head, I'm like, oh yeah, sharp point. It is going to be abrupt. It is going to be abrupt. But as Tyler was saying, if you zoom in, zoom in, zoom in, zoom in, there is going to be eventually at some point, there is going to be a transition, not just an abrupt change. Because it's not at one infinitesimally small point in time.
Yeah.
Because remember, if you say instantaneous, that means one point in time, but how much length is that one point? There is no time interval for that one point. It's one instant.
Miss Steve, that's why, because using MBT, so if you were to like throw a ball, it has to be zero at some point, but if it was a sharp point, then it wouldn't, I mean, it would be not differentiable, right?
Right, but their question is, why does it have to be differentiable? So they were assuming it's not differentiable, so we were trying to think of when would be a case. Does that make sense? But yeah, assuming that motion is, like what Nathan said, if we just assume it in the sense of we just say from now on it's true, and take physics as to know why. But from now on it's true, then yeah, of course, there will have to be a 0 in between the positive and the 0. Okay. Lots of concepts. Sorry, we have to slow down the concepts, meaning like stop talking about them and go through the answers. So, example number 2, there's a graph, right? They're having way too much fun with the waffles in the mouth. They moved on.
Sorry.
At 4. Did you guys figure out it was moving to the right because the velocity was positive?
Yes.
That's actually
If you go to 4 on the graph, don't you have to go up to hit the velocity function? Has nothing to do with the slope. It has to do with when you go to 4. And I wish, actually, can I split screen this? That would be a great idea. Let me go back to the graph. Because there's a few of you, I'm assuming that you all got it right, which is a poor assumption on my part in the sense that that's an unrealistic assumption. Where's my other screen? No. Oh, he's hidden because he's full screen. Okay, let's leave the full screen. Let's move him nowhere. Cool. Go team. I have no idea if we can actually show this though. We can try. Can I do both at once? Okay. Number 1, you have to go to 1, 2, 3, and 4. 4, if you go up, the velocity, I think, was 6. Is that right? Velocity is 6, hence velocity is positive, hence the particle is moving to the right. Number 2, it's asking for when is the particle, or for what time interval is the particle moving to the left. Guys, pause. Don't even think about the graph. Moving to the left. That occurs when?
velocity is negative.
So the best way to do it is to start and say, oh, hey, the particle is moving to the left when the velocity is negative, which occurs, and you haven't even figured out the answer yet. But you have half the answer. You have 1 out of 2 points. So a particle is moving to the left when the velocity is negative, which occurs on, hey, when does the velocity, when do the y values of the velocity function go negative? This whole interval from 5 to 9. From 5 to 9. However, it's going to be open at 5 and closed at 9. Why? Why is it closed at 9? We always keep intervals open, don't we? Velocity is negative down there. Why don't we include 5? Well, isn't velocity 0? So it'd be open at 5.
Yeah.
And it'd be closed at 9. Velocity is 0 at 5. The particle is momentarily, very, very momentarily, at rest. At 9, the particle is still moving to the left because the velocity is still a negative. Number 3. Acceleration, positive or negative? What's it asking for? At
T equals 4.
At t equals 4. At t equals 4, hold on. Acceleration is going to be negative when we have velocity. Help me out.
Slope.
When the slope of velocity is negative, or you can say when velocity is decreasing, right? So acceleration is going to be negative when the slope of velocity is negative. You could have put that. Or when velocity is decreasing. And so at 4 seconds, what's the slope? Down. So therefore acceleration is negative. Or you could have also said what's happening at 4, velocity is decreasing. So either way, acceleration is negative. This one's...
This is like much easier than the APFRQs, right? Like if they were to give us a motion one.
If they were to give you a motion one, they'd have 1 to 2 of these questions and then something to do with probably integration.
Yeah, okay.
Number 4, but you never know which kind, so that's why it's good to go over all these before the particle is moving to the right. Number 4, what is the average acceleration? Guys, there's a formula for that. Average acceleration, average rate of change of, whose acceleration the rate of change of? Velocity. So I need the average acceleration, which is the same thing as the average rate of velocity. And then what's that average rate formula? It'd be f of v, but who's my f? V. So it's not a, it's v. V of 4 minus v of 2 all over 4 minus 2. V of 4 minus v of 2 all over 4 minus 2. You have to get up into your graph, you need to find the 4. At 4, velocity seems to be 6. At 2, velocity seems to be 9. And then we go ahead and plug in, and for sake of you guys understanding, yes, it's negative 3/2, but once again, I wouldn't want you to simplify if it was on the AP. Feet per second is valid because it's feet per second for velocity, second for time. change in v over change in t, v units, t units, which just ends up being feet per second squared. Average acceleration is the average rate of velocity. Go use your average rate formula.
I swear, stop moving left and right.
Yeah.
And then in number 5. Whoa. Number 5. Why is there a negative 3 halves?
Yeah.
What did you just find in number 4? The average rate of change. So this question was building you up to say, hey, this guy, negative 3 halves, if you did number 4 right, you're like, that's the average rate of change. Wait, what theorem? Says the average must equal the instantaneous at some point in an interval. MVT. So number 5 is, yes, of course, MVT says, since velocity is continuous and differentiable, there must be an instant where the instantaneous, there must be a time in that interval where the instantaneous v prime of t must be negative 3 halves, which is the average.
Wait, but it's not guaranteed by MBT.
What do you mean it's not guaranteed?
No such thing as guaranteed.
It's because it's not differentiable. It's not differentiable between. It has to be. It has to
Yeah.
do all the 3.
Oh, Tyler, there is a sharp point.
See, that's what I was like. I was like, wait.
I didn't look at the graph.
Example number 2. What's the,
If it was differentiable, yeah, what's the actual motion going on? I have no idea.
It's probably just made up.
Maybe it's a theoretical motion, that's not actually possible. That's nasty though, that's nasty that they called it velocity and it has a sharp point.
Yeah, okay. No.
But maybe if you zoom in, but they're saying, I don't know, I'm curious as to how it
Yeah,
happens.
I don't.
I don't know either. Struggle. But Chaos, if you thought, yes, MBT, was that good logic? Yes, great logic, but you didn't consider the ifs. And looking at the graph as a whole, can we say velocity is continuous and differentiable looking at this graph? No. Struggle, that's a good question. I need to look that one up on like an English teacher college board or something like that. Because clearly those are sharp points. They are showing them to us for a reason. So therefore, since velocity is not differentiable, which makes sense, but I'll explain it in a second as far as the graph. Since velocity is not differentiable in between 2 and 4, this one doesn't really matter, but this one does. I say, nope, MBT does not apply, so there's no guarantee. Here's a quick struggle. Well, the quick struggle was me not considering the graph or the function that was given to us. I was just considering the math in between here and here. But coming back, guys, isn't v prime a slope?
Yeah.
Couldn't we look at 2? And couldn't we look at 4? And couldn't we mark that slope? Question, is this slope mimicked anywhere in this graph? No. The slope is only this positive that we can approximate using 2 points, or this negative that we can approximate using 2 points. Does it ever go to this? No. Why not? There is no gradual turn. Because there's no gradual turn, there's no guarantee. That's why a function has to be differentiable. There has to be a gradual turn, at which point, oh, it would happen right there, but since there was no gradual turn, that slope is not indicated anywhere. So if you were thinking about the graph, which is exactly what I didn't consider, that would have been pretty obviously a no. But the reason is MBT is not guaranteed since there's a sharp point at 3. Woo, good catch, kiddos. I should keep you around. All right, number 3.
Only 1 year.
Oh, number 6. Okay, number 6, I'm going to teach you more about this a little bit later when we learn definite intervals, but for right now. Number 6. At what time t in a given interval is the particle farthest to the right? Figure that out and why. Sean?
Okay, so we would think upon first look that it's 3 because we're like, oh, it's the highest, but no, we're not talking position.
What is the highest at 3?
So we are
velocity.
Oh,
So we have to go to the point where we have the the most amount of velocity increasing, the positive velocity pushing it farthest to the right. And so the value that has that time is 5 because it has from 0 all the way to 5 we have this positive velocity and it's going to keep going even though the acceleration is decreasing from 3 to 5.
Careful, velocity is decreasing because acceleration is negative.
Yes. And so even though it's decreasing, it's still positive value. So it's going to be going slower. The speed's going to be decreasing, but that doesn't mean that it's still not moving to the right.
So, when you look at the graph of velocity, which was over here, and if you were to think of a sign chart from that graph, if we were to go that way, we could say velocity in between 0 and what are we doing, 9? 0 and 9. Has a 0 at 5. Momentarily comes to a rest at 5. But Sean's saying, hey, look at this part of the graph. All of those velocities are positives. And yeah, some are going up, meaning the particle is speeding up, and we'll talk more about that in a second, but speeding up from 0 to 3 and then slowing down from 0 to 3. But if you take your foot off the accelerator, or even put your foot on the brake, could you still be moving to the right for a bit longer? And the answer is yes. Even though this is a confusing model because of Tyler and I and what it means to have a sharp point. But we can say velocity is increasing, velocity is decreasing, and yet all of those velocities are positive, which means for that entire time the particle is moving to the right. And what we haven't been able to really go in depth is how much it's moving to the right. But we are going to start to tie in that this area of this, well, triangle minus that little triangle is going to be the total change in position that it moved to the right. So not only did it move to the right that whole time, it moved to the right this amount, this area, which is kind of cool. And what's it going to do after 5 to 9? Move to the, well, what's the velocity do?
Minus that area.
Goes negative. So then my particle is going to move to the left, and how much to the left? All of this area, that triangle plus rectangle or that trapezoid. But long story short, it's going to move to the right, the particle move to the right, move to the right, move to the right, and then what's it going to do?
Move to the left.
All the way until 9. Which means, when is it farthest to the right? At the point where it changed direction. Good luck. Okay, example number 3. Nice thing is this one can go faster because what did they give you?
Function.
A function. Life is nicer with a function. So, first of all, at number 1, moving to the right or to the left, you guys should have found a derivative, true?
Yeah.
And when you found a derivative, you should have plugged in 0, and you found out that, hopefully, velocity is positive. V of 0 should have been 9, which is a positive, which means the particle is moving to the right. Good. Number 2. At t equals 1, the velocity increasing or decreasing? What did you guys say?
Decreasing because I have t negative, so I think, okay, yeah.
That was really messy. So for someone who wasn't able to distinguish or didn't know the right answer to begin with, thank you, ma'am.
A of 1 is negative 12.
Given particle velocity is decreasing what?
Because A of 1 is negative 12.
Good. Velocity is decreasing because A of 1 is negative. You would have had to find acceleration and plug in 1. Number 3, find all the values. Sounds like a time interval sign chart to me. Do you guys agree?
Yeah, you know.
Find all the values. You need a sign chart. You guys found your velocity. What were the zeros of velocity?
It was 1 and 3.
1 and 3. Looking at your velocity function and factoring him, you end up with zeros of 1 and 3, and then you have to test. And Sean, what happened when you tested into velocity?
When I tested into velocity, I got positive and positive.
And so for what times, out of all possible times, assuming this particle has been moving from negative infinity and will continue moving to infinity, it will only be moving left between 1 and 3. Open or closed?
Open,
Because at 1 and 3, it's 0. So it's not moving left at 1 and 3. It's momentarily at rest. However, between 1 and 3, it'll be moving left. Because V of t is negative for that interval. Finally, number 4, total distance traveled. Hey, speaking of moving right, moving left, moving right in sign charts, when they cut this off to be 0 and 5, am I able to include my 1 and my 3?
And you know.
So what did we learn yesterday? How would you do the total distance traveled?
You take the interval from 0 to 5.
Absolute value.
Absolute values.
Okay, Tyler, thank you. We're not there yet. X of 1 minus X of 0 plus
absolute value of x of 3 minus x of 1
plus
the absolute value of x of 5 minus x of 3.
you plug it all into your calculator one fell swoop,
And
and you ended up getting?
28.
Okay, that's example 1, that's example 2, and that's example 3. Given a table, given a graph, and given a function. As Tyler said, there might be some additional things that show up in the motion problem on the AP. However, All of those questions I have seen on former FRQs, not all at once, but I have seen them all on former FRQs. Okay, here we go. Worksheet 1, 2, and 3. Sorry, worksheet 3. Situation 1, 2, and 3. Okay, what do you guys say? Absolute value. What effect does it have on numbers?
Make them all.
Sure, makes them always positive, right?
Yes.
Okay, number 2, what effect does taking the absolute value of an entire function have?
It can't go past X or Y.
Yeah. It makes all output values greater than or equal to
All
0.
output or all y values have to be greater than or equal to 0, which means the graph can never go below the x-axis. It'll always stay above. So whatever is above stays above, whatever is below pops up. Okay, how are you guys able to fill in the speeds if you knew the velocities for situation 1?
Absolutely.
Yeah, so didn't you just fill in 1, 2, 4, 5, 16?
Yeah.
Cool. So velocity is doing what? Velocity has what sign?
Positive.
They're all positive, and what's it doing? Because time only goes one direction. So velocity is positive and increasing, yeah? What were all the speeds?
Positive.
Positive, well, because speeds are always positive, and what are the speeds doing?
Increasing.
Okay, so let's put this together. The velocity is positive and increasing. Because velocity is increasing, what must acceleration be?
Positive.
Okay, because of the increasing, decreasing test. However, what was speed doing?
Increasing.
Oh, wouldn't you have thought that? If you graph speed, wouldn't since it's already above the x-axis, wouldn't it just stay the same? Okay, cool, no big deal. So, when velocity is positive and increasing, guess what? Speed is increasing too. How about situation 2?
Alright, it's absolute value, right? You know.
Okay, so you guys should have filled in the speed table. The speed table will be 1, 2, 4, 8, 16. Okay, so let's think through this. Velocity is
Negative.
negative and decreasing. Because velocity is decreasing, acceleration is negative. Oh, so speed is decreasing, right? Wait, what?
Nope.
Why is speed increasing even though velocity is decreasing?
Because there's negative.
Because its negative velocity is going more negative. Because its negative velocity is going more negative. Decreasing means on a number line headed to the left. Remember, if you have a negative velocity being pushed more negative, going more negative, then my speed, the magnitudes are increasing. It's going faster in the left direction. Does that make sense? Okay. Situation 3 is really tricky though. I had someone in here doing it after school, someone who has quite a high grade in calculus, who was just doing the words and not looking at the table. And they totally got it all switched up. Question. What would the graph look like for situation 2?
Well, that actually is, they've graphed the speed graph instead of.
Oh, this is, I was going to say, I was like, wait a minute, that's not right. Okay, good, you're good. This is velocity. Speed says, no, you're not allowed to be down there, so what's it do? And when you flip it, this decreasing in the negative is going to end up in increasing in the positive for speeds, yeah? Okay, situation 3. We have negative velocities that are increasing, right? So we have negative velocities that are increasing. Since they're increasing, acceleration is positive. However, what's going on with speed? So even though acceleration is positive, even though it's pushing the numbers to become or go more to the right, what that means is the magnitudes are, the speed is decreasing. Because if you were to flip this one, ooh, yep, it's going down. Last but not least, we have situation 4, right? Situation 4. You're given a velocity graph that is positive and, there we go. A velocity graph that is positive and decreasing. So you have positive, they're decreasing. Got it. Since the velocity is decreasing, my acceleration is negative from the increasing, decreasing test. And what's speed doing? It's decreasing. So in conclusion, when was the speed increasing? Situations 1 and 2. What was going on in both of those? The only thing that was similar was that the signs were the same between velocity and acceleration. When was the speed decreasing? Situations 3 and 4. And what was going on with the signs? The signs were opposite. So therefore, I want you guys to pass up your motion packets really quickly. I want you to have it turn to the second page so I can see example number whatever's. Worksheet 2. Thank you. Pass them straight up, and as I spot check them, I want you guys to show off whether or not you really get the whole speed increasing, speed decreasing thing. Pass them up, I'll come get them in just a second, but let's recap real quick. When is an object speeding up?
If it's acceleration, it's positive.
When the signs of velocity and acceleration are the same. When is an object slowing down?
If there's a force acting in the opposite direction of its motion.
When the velocity and acceleration have opposite signs. Alright, you can use a pen, you can use a pencil. The possible answers on this will be positive, negative, increasing, or decreasing. The answers, the possible answers are positive, negative, increasing, or decreasing.
What is it like? 100%?
Look at pop quiz. I just want to see how you guys do. Just do the best you can.
We have to put that
Just I haven't been doing it.
Let's go.
Miss, do you color do you grade in?
Please don't use blue, preferably.
Okay,
If
alright.
you can use a different color,
I
that's
only
great.
have a red pen.
Although
so-
technically you're going to be grading it yourselves in just a second, so as long as you have a different color than the color that you're using, it's okay.
Okay. Are the options decreasing?
Positive, negative, increasing, or decreasing. I'm not going to tell you which is where. Positive, negative, increasing, decreasing. Actually, to be honest, but it's not an actual grade. Why don't you see what your logic would be? That's kind of the point. When you're done, flip it over so I can start queuing and you can start finishing. Possible answers are positive, negative, increasing, or decreasing.
Interesting.
Interesting. Well, you get tricked. Once again, the possible things to fill in: positive, negative, increasing, or decreasing. It's one of those four for every single blank. Flip it over when you're done. That way you can start hearing. And if you don't already have a different color pen out, go and grab out a different color pen. That would be great. Remember, More obvious the better. More obvious the better. Are they still working? It's okay. Okay, switching your groups. Okay, don't grade anything on theirs yet, but I want you to look at their answers and whether or not they agree with yours. Just take a second, look at their answers, see if they agree with yours. Don't mark anything yet, but talk it out just a little bit. In your groups, it's okay, talk it out just a little bit. Any discrepancies?
So it has a loss in case she says
No, it's pretty good. I'm pretty good.
So you use the test, so if it's decreasing, okay, well, think about it. So it's like F prime is velocity, so then F double prime. So the rule is if F double prime is negative, that means F prime is decreasing.
I just put positive just in case.
So if F acceleration is negative, that means velocity is decreasing. So it's saying, like,
The velocity is negative.
acceleration is negative, so it's
Is that like saying that it's
speed.
like that is,
And then 5 is the same, but
it's
not
accelerating in the defining direction?
Basically, yeah, when it says it in this context, it's saying like acceleration.
This D for 5?
So you do actually have
This D for 5, when you say that the velocity is negative and increasing, you mean that like it's getting, because it's a negative number, it's getting closer to 0, right? Or is it getting more
Whenever there's
negative?
increasing and decreasing with velocities, what I'm referring to is
Is
the
it-
actual numeric value moving left or moving right.
So is it getting like closer to being positive? Yeah. The,
So that means that
let's see, the speed.
having left over
So like it's below the x-axis, but it keeps getting closer to 0, so yeah.
It's the absolute value, so it's getting smaller.
It's moving to the left, which is velocity.
Yeah, I know that.
Decreasing,
Wait, Nathan, did you say it was getting closer to 0?
basically.
Yeah, okay.
If it's number
Yeah,
five.
yeah, okay. I was pretty sure, I wasn't sure if I meant acceleration was positive or negative. But,
Maybe acceleration is
Alright.
Because let's describe yourself.
yeah, I was pretty sure that was the case. David, you said it again.
I did it for both.
No.
Alright, here we go. Number 1.
Perfect.
If velocity is negative and acceleration is positive, they are working against each other, so speed must be decreasing. If you didn't do it correctly, write it in your color pen. Speed must be decreasing. The signs are opposite. Number 2. If velocity is positive and speed is decreasing, speed is decreasing, the signs must have been opposite. So if velocity is negative, acceleration must be. One more time. The speed is decreasing, the signs must be opposite. If velocity is positive, acceleration must be negative. Number 3. If velocity is positive and decreasing, that could be like okay, this x-axis positive and decreasing. Oh, speed's going to be decreasing also. The signs must have been opposite, which means speed is also decreasing. Number 4, if speed is increasing, signs are the same. So acceleration is negative, velocity must be also negative. And if velocity is negative and increasing, acceleration is positive. The signs are opposite, so speed is
Velocity.
Return the menu.
oh, it's number 6.
Okay, that's D. There could be like 2 answers for some of them.
If the particle is moving to the left, which means velocity is negative,
Misty.
so like speed is decreasing. If velocity is negative, speed is decreasing. The signs must be opposite. No, positive, negative, increasing, decreasing are not synonyms.
So speed is increasing. And
Okay, hold on to them.
negative.
We'll look or tomorrow at what things you missed.
Misty, there could be like for 4, there could be if speed is increasing and acceleration is negative,
today?
No one in here. No one in
then
here.
velocity is negative and decreasing.
What, she said that's, oh, true, you're right.
So no homework tonight?
We can know that for sure.
Yes, because acceleration is definitely negative.
No homework. Study your forever cards.
Misty,
Wait, do we have any more after the?
Someone has curious. The guy's got
Yeah, after the integration. The end of integration.
Oh, the guy's stuck.
What, these are highlights?
No homework.
don't worry, Sarah, I'm the same.
Oh, Friday, not for tomorrow, for Monday.
Yeah.
Starting 4.5. Yes.
Do we have any new forever cards?
We have the motion one with integration. That's the only one though.
Hey, Brian, you said
What's up tonight?
Mark is not there.